used to work in Microsoft. I started off in Hyper-V working on virtual machines, and then I worked on Windows Azure. And I spent a lifetime working with relational databases, and I made the early switch to NoSQL databases about 2.5 years ago, and I've been working with Mongo ever since. So I have a company called ScaleGrid, which essentially specializes in NoSQL databases, and our current offering is called Mongo Director. It's basically a hosted SaaS offering, which basically helps you manage MongoDB in the cloud of your choice. And a lot of my learning and understanding is in the context of my learning of Mongo. So, a lot of it is extrapolation, but a lot of it is relevant. So, let's start. So, what do you guys think NoSQL is? Right? So, you can ask different people and you'll get different answers. Some people will say it's not SQL. Some people will say it's not only SQL, right? Oh. The reality is nobody knows, right? It's a term that just, was. If you go back to the origins of the term, right? There was a researcher in Washington D.C. area around 1999. He built a database that didn't support SQL-like syntax, so he called it NoSQL database. But the term didn't catch on. Say till about 2009. In one of the conferences, Eric Evans from Rackspace, he decided to call these class of databases NoSQL databases. And it's at that point that this term sort of caught on. And,
because they didn't support a SQL.
I'll get to it. It's really tricky. And essentially, it's a class of databases that don't have a relational scheme. Okay? And here's the catch. NoSQL databases support SQL. Because what they are referring to is, there is a SQL as in the relational schema, and there is SQL as in the language, right? The SQL language is T-SQL. If you ask the purists, that's what they call it, T-SQL, right?
Yep.
So plenty of NoSQL databases support T-SQL. So for example, you can use your favorite SQL query syntax. You can talk to Mongo, you can talk to Cassandra, you can talk to HBase, because people have written like SQL connectors and all that. So the confusion in the term is there is SQL, the database, and there is SQL, the language, right? And essentially what it means at a high level is it's not a relational database. So it represents a class of databases where data is not represented using relational. And it may or may not support the SQL language.
But it still support joins.
Right? It depends.
Okay, depends.
So for example, Mongo doesn't support joins.
Okay.
But what happens is people write SQL query connectors to Mongo which support joins.
Okay.
So it's a question of, is it inherently supported in the database,
okay,
or is it supported to some layer on top of it?
Okay.
And of course,
and
if it's supported through a layer,
yes,
it's not very efficient.
Okay.
So there's no.
I was thinking MapReduce is sort of a join.
MapReduce is different, so it's not really a join.
I mean, you can achieve the join functionality using MapReduce.
I mean, you can achieve anything in this world using MapReduce because it's such a generic sort of paradigm. It's basically a split, run, collect results. Right? You can do anything. Any computation operation in the world you can model using MapReduce. So you can definitely do joins using MapReduce, but I don't think that's a join in the sense you're talking in. Okay. And if you look at the history of these databases, right, most of them started in the early 2000s, and a lot of it comes from the need to scale relational databases. If you look at the amount of data we are producing today, right, if there are some rules of thumb, like for example, 80% of the world's data has been generated in the last 2 years. So essentially, the amount of data we are generating is growing at an exponential scale, right? So if you look at exabytes and petabytes are not very uncommon anymore. Any small shop anywhere will have petabytes of data. Just go look at some social analytics shop. They have high terabytes of data. If you go to Twitter, I'm sure there are exabytes of data. YouTube, it's just data is growing exponentially, and a lot of these databases came from that need. And we started in early 2000, where the options were basically there were all these web startups doing all these web scale tasks, and they were doing it with MySQL and essentially just manually sharding and setting everything up, and they just got really frustrated with it, and that's essentially where it all started, right? So for example, the founders of MongoDB, I don't know if you guys know it or not, they're actually the founders of DoubleClick. the ad sort of analytics company that got sold for like billions of dollars to Google. So they had so much trouble building the backend for DoubleClick. They decided there was time to build a new sort of database that's more in tune with the web paradigm. So they actually, after they sold to DoubleClick to Google, they started MongoDB. And there are a lot of stories like that. And essentially, like, you know, the lack of scale, lack of easy scale with relational databases is what gave, you know, rise to these paradigms. And there are like a gazillion ways to classify these databases. And you can go online and you can read, and there are, like, you know, you can classify based on data model, you can classify based on write characteristics, you know, performance. You can characterize based on their consistency model. And there are just many ways to spin these things, right? So I've chosen a very simple way here right now. It's based on data model. There are like this is not the complete set, just a few high-level popular ones. Like, you know, there's a key-value pair. There are graph databases. There are column-wide stores, and there are document databases. Like with document databases, you know, Couch and Mongo are popular. With column store databases, you know, HBase and Cassandra are very popular. And graph databases, Neo4j is popular. There's GraphLab, which is based in Seattle. They are also very popular. And of course, there's a key-value store. There are a whole bunch of them. Oracle has one. I think HANA also falls into the key-value store, if I'm not wrong. Again, it depends.
Yeah.
It may or may not, because it's also fuzzy. It actually depends exactly on what the database is, what the scenario is. There's no easy way to classify it. If you guys want to look at the entire sort of topology, right, there are about like 25, 30 of these new databases. And there is like a more like a detailed topology of how you look at it, whether it's key value, or whether it's like a white column big table, whether it's a graph. There's also another class of databases called NoSQL databases. Think of them as like a faster version of SQL databases. They support full complete relational model, SQL language, but they have relaxed some restrictions for more scalability. That's like MolDB and a few of the other databases over there. So this is a very active space. The database space has been fairly dormant for about 3 decades now, and over the last 5 to 6 years, it's just exploded. And there's a lot of interesting innovation going on across all these spaces. And will all of them survive? Definitely not, right? So, but I think a major portion of them are going to survive. And the databases today are like a $60 billion industry, right? And I think these databases will make a reasonably sized dent in that industry, right? Nobody here is going to bet that it's going to remain the same and all these guys are going to go away. Where they're going to make the dent and what scenario, it's all very case by case basis. But you know, some of them are going to do pretty well. And, even if they do reasonably well, they'll make $6 billion. That's the size of this market.
My goodness.
And you know, it depends on your scenario. You can't really, you can't learn about everything because they're all complicated systems, right? So you just have to look at your scenario. You have to look at your needs. You have to look at where you want something extra over relational databases, and then you can start digging into it. Right now, most of my work, I'm focused on document databases, specifically on Mongo. So I spend almost like 90% of my time just on Mongo. But I know enough about the other databases to get into trouble, but most of my knowledge is in Mongo.
Is there a reason for that, or why did you choose Mongo?
Yeah, I was telling Rob that I'm just following the money. So I started off with SQL Server. And enough people just kept bugging me about Mongo, so I started doing it about 2.5 years ago. And I've not had a reason to stop doing it.
Oh.
So it's just more and more people are adopting it. And so my hunch, it's a bold prediction, but I feel that the M in the LAMP stack is going to become Mongo pretty soon. And it's just that I just see such a furious rate of growth that all the startups using MySQL, they're moving to Mongo. And there are just so many reasons. And they're seeing furious growth in web space. We can talk a little bit about all the differences and what the key differences are and what you look for and stuff like that. One of the most important differences between like a relational database and NoSQL databases and the flexibility of the database model, right? So in a relational database, everything is like tables and columns. Everything is fixed beforehand. You know all the width.
Yep.
Each row is exactly similar to what the previous row was.
Yep.
And the beauty of NoSQL database is it's very flexible. You can store structured data like a relational database. You can store semi-structured data. You can also store unstructured data, like complete log files. Just dump it in the database and it will do just fine. Like for example, right? Mongo stores JSON. When you say document in Mongo, it's essentially a JSON snippet, right? If you don't know what JSON is, it's basically JavaScript object notation. It's a way of serializing objects in JavaScript, and it's very simple, very clean, and it has basically become the de facto format for object serialization. At a point in time, it used to be XML, but XML just got so convoluted and so verbose, and essentially you find very little XML anymore. Mostly all serialization is done through JSON, and that's the native format for Mongo. So essentially, if you take a table in Mongo, it's called a collection. Every row in Mongo is a JSON document. And the beauty and the flexibility of it is that document can contain within itself any number of documents. So for example, if you want to store the snippet in a relational table, you have to make different tables, you normalize it, you set up relations. Whereas in Mongo, it just all fits into one row. And the beauty is, it recognizes it as a first-class citizen. So for example, you can query like person.firstname or person.address.street. You can actually run, just like in SQL, you would query by columns. These are all like first-class columns in the database. So for example, if I want to add an index, I can add an index on person.address.street. And you can query on it. Whereas if you store this in a relational model, you can just dump the JSON into a relational database, but so it's of no use because it's not queryable. Now, if you want to query it, you have to break it down into like different tables, normalize it, and set up relations. So in most schemas, simple schemas, it makes a big difference because you can just store it as JSON, and you can retrieve it directly, query from the database. And nowadays, the new frameworks people are writing, essentially like everybody's working in objects now. And objects are getting serialized to the database, and so JSON is kind of the natural format at which they're being serialized. So it translates very easily to and from objects. And JavaScript is the rage nowadays. There is a lot of development energy in JavaScript. People are writing server, client, everything is being written in JavaScript now. And JavaScript just works wonderfully with JSON. So any database that supports JSON integrates very easily with JavaScript. Right? And this is just one example of a document. For example, let's say you have some sort of client application where you have to store Word documents, right? You can just put it right in the DB. If you have spent any time with relational databases, storing file structures with relational databases is really complicated. Typically, you don't put the actual file data in the database. You store a reference to it, store it somewhere else.
Yeah.
And then the problem arises, right? Database has mirrors, it has backups. So what about the file data? So you have to go in and mirror all that process you did for the database. You have to mirror it for the files. Somebody has to replicate the files. When you delete it, you have to delete both copies.
Wow.
And when you set up DR, you have to set up the same thing. A lot of the NoSQL databases, they get past that because you can store files and structured data in the same database. So you just plonk it in as a binary field and put your data there. The database will do the right thing. And you can store both your DB and your files in the same place. And a lot of the startups today, right, this is what they do. Because they have a lot of user-generated content, and they don't want to deal with content separate from the database. So they go to a NoSQL database like Mongo, and they just put all the content, everything. And they have the structured data, and the user-generated data also gets put into Mongo. And that way, they don't have to worry about or even come up with a file management sort of scenario. Right? It's all database for them. It doesn't matter what's inside; it's just the database. And it also scales out, and we can talk about that as well.
So can you have, for example, you've got your main container, I guess I would say, as person.
Yeah.
So can you have then, you can have an infinite number of streets, for example, that person.
Yeah. There'll be a size limitation in a document. I think in current versions of Mongo, it's about 16 megs.
Okay.
Each document is limited to 16 megs. But you can have any number you want. And the beauty is not that you can have any number. The beauty is that you can query and index by it.
Okay.
Because you can store this even in SQL, right? You can just do like
Yeah.
an in-text field or nvarchar field.
Yep.
Just put all there.
Yep.
But the problem is you can't query it. Because it doesn't really have that, it doesn't recognize it as a first-class format, right? But in Mongo, you put in a field, and you can say, okay, find me all people who live in street called Peter. And you can just form your query based on that. And there are some other advantages. It's schema-less, and essentially what that means is, in relational database, every table, if you take a table, every row has to be identical in structure to another row. In a NoSQL database, there is no concept of a schema, so every row can be different. So you can store a file in one row, and you can store like a JSON document in one, and you can store another JSON document in another row. And it's a double-edged sword, as you can imagine, because at the end of the day, there's always schema somewhere. Either it's in the DB or it's in the code. Because if you can have multiple formats, then your code will need to be aware of those multiple formats and do the right thing. But the thing is, the database gives you the flexibility that essentially every row can be different. There's no concept of a rigid structure.
When if you let's say the earlier document you showed, you had 3 fields and another subfield, right? And let's say by mistake I inserted another document with, I didn't have all the 3 but had only 2. It still allows me to insert it.
Yeah.
But when by chance if I make a mistake, I forget one field, it still allows me to insert it.
Yes.
But when I query, I get into some errors because I forgot one field in one of the documents, and therefore my class is not matching to that. And so how do you
could get it? And this is the flip side of flexibility, right? When you have a lot of flexibility, you can definitely shoot. You have enough flexibility to shoot yourself in the foot, right? And the question is
are there any good guidelines you can give?
There are definitely guidelines, but the database doesn't enforce it, right? It's essentially your code and your validation that has to enforce it, and to make sure that data that you don't like shouldn't go into the database, right? And let's say, for example, you miss the last name,
correct.
Right?
It still allows you
so all your queries will work, all your indexes will work. It's just that you will not be able to, if you have a query that runs by last name, it just will silently not return that row, right?
Oh. Okay, so you can't enforce in this thing that you say if you write for every document you write, you have to have a first name and a last name and at least one address. You can't enforce that?
There are some other ways, like for example, you could do you could have a unique index on that field, and that will require that field will be not null. There are some roundabout ways to do it, but looking at it from a puristic sense, right, there is no way to do it. And the database doesn't. The database tells you, I'm giving you the flexibility. It's up to you to be careful with it.
Oh, okay.
Right? And essentially, you can put anything in each row, and it's up to you on how you use it.
Because there's no concept of a schema.
There's no concept of a schema. And there are people who use NoSQL just like SQL, where every row is the same, and that's fine. Yeah? And that's okay. Because that's what the app needs. Right? Ultimately, you have to do what your app needs. And the beauty of this model is it gives you the whole gamut. And you can turn the dial as much as you want. And of course, you have to be careful. It comes with a lot of risk. And that's what I tell people, right? I don't buy the schema-less argument because essentially your schema has now moved from the database to your code. And you look at the code and they'll be like, what people do is they put inside the schema, they add a version field, right? So they'll be in the code, you'll see if version equals to 1, then there's no address. If version equals to 2, it's the full address. So essentially your schema has just moved places. So I don't buy the schema-less argument, but I can see some systems where it's useful, where there's different amounts of data of different type, you can put them all together.
And so you can have transaction across documents.
So again, it depends on the system. All the NoSQL systems are different when it comes to transactions. With MongoDB, you can have transactions on a single document. Essentially, it means like a single row. And anytime you span documents, you don't have transactions.
How does it enforce concurrency there? I mean,
concurrency is only at the level of a single document. So if two people are editing this person, it enforces it. But if you are editing two different persons, yeah.
Same record for two people, how does it enforce? Like, is a record locking concept like?
Yeah, that you can enforce. Basically, there is a primary key, right? So you can set the primary key and it will ensure that there are no duplicates and stuff like that. And there are indexes, you can add unique indexes. But in terms of the data, if you look at it in a theoretical perspective, in terms of the asset properties, it's only at the document level. And this is Mongo. And everybody else is different. And there are versions of Mongo that support full asset. Like there is a company called Tokutech, which builds TokuMX, which is an open source clone of Mongo. And they support full asset properties, full SQL, full asset, everything. It's basically your SQL set of features in Mongo. You know, it has full asset properties. You can use the SQL query language, but that's the beauty of this model, right? You can, depending on what you want, you can turn the dial and the product as well. One of the other important things that all these NoSQL databases they are focused on is like developer agility. Like, you know, if you remember the time like when you were working with SQL databases and how long it took for you to grok the concept of SQL schema and normalization and getting in and what is the right thing and the 5 chords laws of normalization. And people have spent months just trying to figure that out. And what the NoSQL guys have done well is they've just focused on developer agility. Anybody with reasonable skills can get up and running within an hour. Like, you know, if we are just building a simple app, because what they've done is there is like an impedance mismatch between SQL and application code, right? Most developers don't like working with SQL. They don't like writing stored procedures because they're difficult to debug, difficult to manage. And people who do SQL don't like working on app code. So there is an impedance mismatch between the two. Now what they've done is they've gotten rid of this impedance mismatch because there's no SQL code anymore. You're all just working in your code, you know, whether it is Python or whether it's Java or it's .NET or C#, everything is in code, and you're always just working with objects. And your database has essentially become a library, and that's a pretty lofty goal, but I think most of them have done a good job of getting there. Like, you know, like if you guys have never used Mongo and you go and download and install it today, I'm pretty sure within the next hour you will finish your first app and it will be up and running.
I did over the weekend this app.
How long did it take you?
I did over the weekend. I mean, from start to finish, I did over the weekend this app. I mean, it's not a big app, but it's running on a computer.
Yeah, it's very simple, and they focus on being able to like get off the blocks quickly and get in and basically focus on your app. Don't worry about all the other. You don't have to worry about stored procedures and T-SQL and stuff like that. You just come in and very easy to get started. And a lot of it is the paradigm itself. A lot of it is also the tooling they've built around it. So it's a little bit of both. And most developers love these NoSQL databases because they don't have to deal with SQL code. It's all it's in a domain they understand. It's all libraries. They work with objects. Most developers are very happy with it. And also these NoSQL databases, they're also on the cutting edge of what developers want today, right? So if you look at the general landscape of what people are building today, right? People are building SaaS applications, or people are building mobile applications with backends, right? And these NoSQL databases, they have a feature set that is tuned for these sort of scenarios. Like for example, if they're passing around JSON from the app to the web server to the database, Mongo fits perfectly. And if they're doing a lot of geo-related queries, as Rob will tell you, right? Mongo in terms of geo queries is just so like light years ahead of everybody else. And one of the reasons for that is one of their early customers was Foursquare. And Foursquare and Mongo, they have common investors and they share a common person on the board. So Foursquare was one of the earlier Mongo users. And they basically drove all the geo-related functionalities into Mongo, which is why today it's so easy to do like any sort of location-based queries, in whether it's a square or a circle, or you can do all sorts of rectangle, and it's just amazing in terms of geo queries, right? If you went with some other database today, you'll have to actually implement all that yourself. There are libraries for it, but it's something as an end developer, it's not something you want to deal with. It's not your expertise. You just want to know how many restaurants are located within like 5 square miles given this particular lat and long. That's all you want, right? You don't care about the algorithm. Most people don't, but some people do. But most people don't, right? They just want the results and the database gives it. Today it is the way it is, but I'm sure other databases will catch up as well. Postgre is also catching up pretty fast, and they're also adding a lot of these. They also have a lot of native JSON functionality. They have a lot of geo functionality as well. And, another important trend that I'm seeing is if you look at the new frameworks that are coming out, like Node.js, Meteor.js, all of them are built-in integration with, like for example, Mongo. You can't really do Node.js without Mongo because it's all JavaScript, all JS. And it assumes that there's Mongo in the system. And as more and more of these frameworks become prevalent, these databases will grow along with those frameworks. And today, very few people write in PHP or Python. I'm seeing more and more people write everything in Node. And, I think the people doing Java, .NET, they are still doing Java, .NET. But the people doing like Python and PHP, I see them slowly moving towards Node. And as they make that change, they will move to Mongo as well because that framework just brings in Mongo there. Right. And so there are other frameworks. They will in this way. I kind of see a lot of these more and more adoption for these NoSQL databases.
Are there any licensing requirements for Mongo?
So Mongo is an open source database, so you can use the open source version for free. They do have an enterprise version, and if you want, they have extra features like Kerberos authentication, a lot more enterprise features on it. So that you have to pay. And the cost, other important difference is cost between relational and NoSQL. Most of the NoSQL databases are open source, except I think MarkLogic is the only one that's closed source. And just to get started, do something on premise. It's a lot easier than compare. If you have to get started with Oracle Exadata, you have to pay like $1 million to start with. Right? I think those people are going to hurt a lot over the next 5 years. And the last but most important aspect of these NoSQL databases is scaling. If you look historically, right, how people scaled relational databases, essentially what they did was the first one. They did just scale up. Like, if you're having trouble with your servers, you go and buy a bigger and better server, move all your contents over there, run it for the next couple of years. Then if it has scale issues, you go and buy the latest server again, and you keep moving machines like that. And the problem with that model is pretty soon you hit a limit after which you can't scale. And especially if you're looking at web properties, there's just no way you can fit an entire property in one box. And another important thing is cost. As you go into the bigger and bigger boxes, their cost also increases exponentially. After a certain limit, they just cost out. So this is basically the main problem which most of the web startups hit in early 2000s, because they were having so much load, but they couldn't do it with one server, and they needed a way to scale out. And what you do in scale out is essentially you, instead of buying big fat server, you buy a number of small medium servers, and your database essentially should be able to spread the load across all your servers. And that's essentially what you would call a scale out. And all the NoSQL databases, without an exception, have scale out built in. Like for example, if I had to, if you take a sample database and I had to get like 1,000 requests per second done in SQL, I'd have to keep buying bigger and bigger servers. But to get the same thing in Mongo, I would probably buy like 5 or 6 smaller servers. I would scale them out. And if I was still having trouble, I would go in and keep adding servers till I scale up. So theoretically, as long as your data is partitionable, your scale out is infinite theoretically. If you have data that can't be partitioned, then you're in the same problem. But if you're able to partition your data, then theoretically you can scale infinitely.
So you still need design in terms of partitioning.
Yes.
So you need a kind of partitioning key or something.
Yes. So if you look at it, right, let's say for example, let's look at this. Yeah, let's say for example this, right?
Yeah.
So let's say you wanted to scale this to like 1 million reads per second or something, right? So you would have like a partition key. Maybe the partition key is last name. So all people from like A to H go to the first partition. People from J to something go to the second partition. So it's just a
hotspot. Just joking.
yeah.
Yeah.
And then the beauty of these models is even if you start with the partition, you can always change the partitioning dynamically.
Yeah, you can do hashing, whatever it is.
Yeah,
right?
you can do hashing, and if the database notices that there is a big load, you can actually ask it to partition again, so it will keep spreading.
Okay.
So all of them have this partitioning built in. So for example, if you add a new partition, it automatically rebalance everything.
So each different object could have different partitioning.
Yeah.
Okay,
So essentially,
so
there is a you have to identify the partition key,
Okay.
and you
For which piece of data, for example?
yeah. So for each table,
Okay.
you identify the partition key.
Okay.
So essentially, when you give a row of data, it will look at the partition key and decide which partition it has to go.
You still have the concept of table in non-SQL?
Oh,
Or you talk
it
about
depends. For example, Mongo, it's called a collection.
Okay.
Collection, basically, a table is a collection, a row is a document.
Okay.
So, but it maps, it's analogous.
So each connection should have a partition.
Yeah,
key.
each collection will have a partition key, and we do have some examples here. So essentially, how it works is, instead of directly talking to the servers,
Okay.
there is something called a shard router. Basically, a partition is called a shard, and there is something called a shard router. Okay, so a client just talks to the shard router, and the shard router, based on your query, it will identify which partition it goes to, and it automatically redirect the query to the right partition. So at the back end, you can have all these shards. You can dynamically add them. You can dynamically rebalance them, and it has something called config servers. The config servers essentially store the mapping, saying, okay, for this collection, this range is in this shard, this range is in that shard.
You still automatically
No.
this mapping, or you don't I do not have to design the mapping.
No, you don't have to design.
Based
You
on
just
your
have to-
partition key, automatically
Yeah.
this mapping.
Yeah.
Okay.
I mean, if you want to, you can.
Okay.
You can dig deep and you can say, don't automatically partition.
Okay.
I will tell you exactly what goes into what partition.
Okay.
You can do it if you want, but automatically it does the partitioning based on sizes.
Okay.
So based on data size, it will partition.
Most of the startup company, for example, we are saying, okay, and this guy come from Microsoft, and just learn Mongo, and start with a small database.
Yeah.
The initial very likely do not consider partitioning at
Yeah.
all.
Yeah.
Then later on, the data grow bigger,
Yeah.
right?
Yeah.
So to do a repartitioning, how much work that would be? Data migration.
Well, again, it depends on the data.
Okay.
Let's say your data already has a good partition key,
Okay.
and your queries are all using the key, then it's fairly simple.
Okay.
But let's say that your data doesn't have a good partition key, or you didn't do a good job with the partition. If your data is not inherently partitionable, then you're in trouble.
Okay. It's partitionable, but we did not consider partitioning
Yeah.
initially, but
Yeah.
have a good partitioning key.
Yeah.
So that should
then
be.
it's fairly trivial.
Or it's very simple.
That's fine.
Okay.
So what we do is, there is something called a replica set.
Okay.
And typically it's a primary, a secondary, and an arbiter.
Okay.
That's a highly available configuration typical highly available configuration that you would go into production with. There's also something called a standalone instance. Typically people use it for development and testing because it's just one server, right?
Okay.
So if you go to production, you typically go with a replica set, which is a primary, a secondary, and a arbiter, right? And the beauty of that model is even in that model, it is automatic failover. Think of it as a SQL mirror.
Yes.
So when the primary fails over, other guy takes over.
Okay.
And when it comes back, it will automatically join the set and stuff like that. So most people start with just those 3 servers.
Okay.
Now if you start with that, you can add on you can bolt on the shard later.
Okay.
So you can come back and say, hey, I'm going to start with just one shard right now.
Okay.
And you can add the shard routers and config servers. And then as you scale, you can add more shards.
Okay.
So a lot of the startups I work with, which have a tendency to have data that grow continuously, I basically get them to start with just one shard.
Okay.
So they basically have those 3 servers in shard 1,
Okay.
and they have the shard router and the config servers. So they're all set for sharding.
Okay.
And as the data grows, they can continue to add more shards. And that's the beauty of the model, right? I remember in old SQL days in Microsoft, we used to do this manually. Like we had all these shards set up, and we would run these separate SQL servers to do the configuration. And when the query used to come in at the app level, we used to check to see which shard to go to and then
The routing.
route it there.
Yes.
Now all that is automated. And the problem with that model was if one shard got full, then it was our responsibility again to do all the splitting.
So another partitioning.
Yeah. So in this case, all that dog work is done by the database. So it will automatically, if you, let's say you have 4 shards now, right?
Yes.
And let's say you have 12 chunks of data. So it will basically give 3 chunks to each shard. Now if you go in and add one more shard, it will again go and redistribute the shards among all the databases. So what it does is it takes your data, splits into chunks, and distributes the chunks evenly across all the shards.
In the background.
Yeah, and it does in the background,
Okay.
so your queries don't fail. And as soon as it's done, as soon as the transfer is done, it will automatically update the config server.
Okay.
So subsequent queries will go to the right shard. So there's a lot of complexity, and
And also the failover is also very good on this, right?
yeah, failover is also very good
Extremely good.
and
Very easy to do it also.
very easy to do. And so most people start with just a single replica set. What you do with that replica set, right? Like for example, let's say you're running in a cloud. Every cloud has a concept of an availability zone or something like that. Which basically they'll guarantee you that, or a data center, they'll guarantee that not more than one data center will go down over time. Right? And so essentially what you do is you put the primary in one availability zone, you put the secondary in a different availability zone, and you put the arbiter in a third availability zone. And essentially what you guarantee is not more than one instance is down at any point of time. Right? So essentially your quorum will be up and your database will be fine. If more than one goes down, then there's no quorum and your database becomes reload. And again, they have identified all the issues they faced as part of their scale, and almost all the NoSQL databases have done a fabulous job with scale out. Like even Cassandra is amazing with scale out. Right? Cassandra takes it even further. Mongo is mostly single master write, and everybody has reads. Cassandra is multi-master write. So you can write to all of them and it will do the sync up.
Merge.